So let's see examples. Number 1. The question says, determine if the lines y equals minus 3x plus 2 and 3x plus y equals 4 are parallel. Determine if the lines y equals minus 3x plus 2 and 3x plus y equals 4 are parallel. So when you see this question, what will you do? When you see this type of question, what do you think would be appropriate for you to do? Ade, are you there?
Yes, I am. I'm writing down the question and the
All
title.
right. Why I don't write the question, let me know.
Yes, sir. Don't write the question, sir.
All right. Now, do you have idea of what to do?
Am I gonna try and make the second equation just y equals the something, and then now should it, since equation 1 has a gradient of minus 3x and equation 2 has a gradient of minus 3x.
Very good. Very good.
They are
So from the
parallel.
first line,
That's gonna
the
go.
equation y equals minus 3x plus 2. If you relate that to y equals mx plus c. So that suggests that m1, if you want to, is minus 3. So for the second equation, which is 3x plus y equals 4, make y the subject as well. So y equals minus 3x plus 4. Now, if you also relate that to y equals to mx plus c, so we can say m2 now equals minus 3. And condition for parallel lines is that the gradient must be the same. So m1 equals m2 equals minus 3. Hence, the lines are parallel. That's good. So that answers that. So write that quickly. So while you are writing that, let me give another example. This one says, find the equation of the line which is, find the equation of the line which is parallel to y equals 1 over 2x plus 3 and passes through the point 6 comma minus 7. So when you're done writing the first example, quickly write that.
Yeah,
Done?
done, sir. Yes, I'm done.
Okay, you've written the second question too.
Yes, sir.
Okay, so do you have idea of what to do? Find the equation of the line which is parallel to y equals 1 over 2x plus 3 and passes through the point 6 minus 7. So in other words, you should find the equation of the line that passes through that point 6 comma minus 7, but that line is now parallel to y equals 1 over 2x plus 3. So how do you intend to do that? Are you attempting it already? Are
What should do? Yes, sir.
are you attempting the question already?
No, what was the question you asked me? I thought you said, what do you think you should do first?
So yes, what do you do first?
You
You
have to
have,
get the coordinates 6 minus 7 to an equation, don't you? Wait, equation of the
no.
line
If you
which
do
is
that,
parallel to
that
y.
won't solve the problem.
If
We are looking for the equation of the line that passes through the coordinate 6 comma minus 7. That's what we are looking for.
Oh, we first get the gradient.
From where?
We identify the gradient.
So where would the gradient come from?
The one and a half x. So the gradient's 1.5.
Very good. Very good. So you will say that since the line is parallel to another line, so from you say since, so this is our solution now. Since the line that passes through y equals, that passes through 6 comma minus 7 is parallel to y equals 1 over 2x plus 3. Then the gradient m is 1 over 2. Is that clear? So you now use the formula y minus y1 equals m into x minus x1. Is that clear?
Yes, sir.
So you now substitute the point. The point 6 comma minus 7 is the y1 x1 that you are looking for. So this is x1, this is y1. So you now plug it in there, and you now have y minus 7 equals 1 over 2 into x minus 6. And that gives y plus 7 equals 1 over 2x minus 3, which you can rearrange. So you have y equals 1 over 2x minus 10. If you so desire it that way. And if you want to write it in the form ax plus by plus c or equals to c, you can do that. Does that make sense to you?
Yes, sir.
So this is the equation of the line that is parallel to that. And from the diagram I gave you last week, you will see that the condition for being parallel, you have different lines with the same gradient, but having different intersects. So you can see that it's the intercept that differs now. For the first one, the intercept at y is 3. Now this one is at minus 10. Is that clear?
Yes, sir.
Okay. So write that quickly. When you're done writing, let me know. So let's see another example. Hope you are done
Yes, sir.
writing this.
Done.
Okay. So let's see the third example. This one says, determine if 4x minus 6y equals 3 and 2y equals 8 minus 3s are perpendicular. Determine if they are perpendicular. So write that. When you are done writing, let me know.
Yes, sir.
Done? Okay. So to do this, you know the condition for lines to be perpendicular. You said the product of their gradient will give us -1. So, and that means in each case, I will have to find the gradient. So 4x minus 6y equals 3. I will make y the subject there in order to find the gradient. So minus 6y equals minus 4x plus 3. Divide through by minus 6, so you have y equals 4 over 6x minus 3 over 6. That's divided by minus 6. So reduce that, 2 here 2, 2 here 3. So you have that to be 2 over 3x minus 1 over 2. So this implies that m1 is 2 over 3. Then for the second equation, 2y equals minus 3x plus 8. Just rearranging this. Divide both sides by 2. So you have y equals minus 3 over 2x plus 4. So this implies that m2 is minus 3 over 2. Now, if they are perpendicular, m1 times m2 should give me -1. So if I multiply now, 2 over 3 times minus 3 over 2. So this here 1, this here 1, this here 1, this here 1. So I have 1 times -1, which is -1. Hence, the lines are perpendicular. the lines are perpendicular. So I'm using the symbol for perpendicular to show that they are perpendicular. All right. Is that clear? Any question on this?
No, sir.
All right. So when you're done writing, let me know. Then we'll see another example.
Okay, so I'm done.
Okay. So let's see another example. Let me clean this. I don't want to be going to new page, that's why. Example 4 now, right?
Yes, sir.
Okay. Now this one says find the equation of the line which find the equation of the line which is perpendicular to y equals 1 minus 3x and passes through 9,8. So let me just start the solution straight away. Then now write everything together. Now find the equation of the line which is perpendicular to this line, and that line passes through this point. So what you need to do is to determine the gradient of that line given. So this suggests that M1 is minus 3. And since you have been told that it's perpendicular to another line, that means M2 will be minus 1 over M1. And that is 1 over 3 when you substitute minus 3 for M1. So Y minus Y1 equals M into X minus X1. So the M in this context will now be M2. So the point X1, Y1 is the 9,8 given that the line passes through. So you now substitute that in there. So you have Y minus 8 equals minus 1 over 3 into X minus 9. You can open up the brackets if you so wish, or you cross multiply. Y minus 8 equals minus 1 over 3x plus 3. That's minus 1 over 3 times 9, minus 9. So you have plus 3. So y equals minus 1 over 3x plus 11. So that's the equation of the perpendicular to y equals 1 minus 3x. Is that clear to you?
Yes, sir.
All right. So when you're done writing, let me know. We'll now consider another question.
Done, sir.
Okay. So let me go to another page. So I will target exercise because I want to see your attempt. So here is the question. So the question is the diagram shows a rectangle. The diagram shows a rectangle A, B, C, D, in which point A is 0,8 and point B is 4,0. The diagonal AC has equation HY plus X equals to 64. So the question now says, find by calculation coordinates of C and D. Coordinates of C and D. So write the question, draw a diagram, write the question. So when you're done with that, let me know.
Yes, sir.
Okay. should be through writing question.
Almost, sir.
Okay.
It's can you move down the thing? Is there a way to?
Can I move it down?
Yes, sir. I've been trying to move it down, but I can't. Is there?
No,
Yes,
this
sir.
one
Can
is
we
not
wipe it
scrolling.
down?
Find by calculation coordinate of C and D. Is that clear?
Coordinate C and B. C and D?
C and D, yes. Find by calculation, comma, coordinate of C and D. Does that make sense?
Yes, sir.
Okay.
C and D. Yes, sir.
Okay. Now, can you attempt it?
Okay.
Do you understand what to do?
No, sir. Can you go through it, please?
Okay. Now, the first thing of note is the shape. You can see that the question says the shape is rectangle. And you know quite all right that for a rectangle, there are some properties that you must know for a rectangle. One of them is that it has two pairs of parallel sides. So sides AB is parallel to CD. Do you agree with that?
Yes, sir.
AD is also parallel to BC. Now, another thing you must take note of in rectangle is that the corners of the rectangle are perpendicular, are right angle. So that means that this place is 90, this place is 90, this place is 90, this place is 90. All the corners are perpendicular, and that suggests to you that line AB is perpendicular to line BC. Also, line AD is perpendicular to line CD. Or you want to say that BC is perpendicular to CD. Or AD is perpendicular to AB. Hope I'm making sense.
Yes, sir.
Okay. Now, I've been given the coordinates of A and B. So I can find the gradient of line AB. So I will start by saying gradient of line AB equals y2 minus y1 over s2 minus x1. No, that's our formula. And that means AB, since I've said AB, so I'm going to take s2 y2 from B, while I will take s1 y1 from A. All right? So that will be 0 minus 8 over 4 minus 0. So I'm taking s2 y2 from B and s1 y1 from A. So that will give us minus 8 over 4, which is minus 2. Now, since I've determined the gradient of AB, and we have said that AB and CD are parallel, meaning that they will have the same gradient. So gradient of CD is equal to gradient of AB, and that equals minus 2. That equals minus 2. Understood?
Yes, sir.
Okay. Now, I can also determine gradient of BC. Because BC is perpendicular to AB. So that will be minus 1 over MAB. And that will be minus 1 over, what is the gradient of AB? You said minus 2. So minus 2, and that gives us 1 over 2. So gradient of BC is 1 over 2. I've determined the gradient of line BC, AB, CD. Hope I'm communicating.
Yes, sir.
Similarly, I can also determine gradient of CD. Since I've determined gradient of BC, and I know that BC and CD are also what? Are also perpendicular.
Yes, sir.
Or, no, I've determined that already here. That's minus 2. Then, okay, I can determine gradient of AD. Gradient of AD. Now, AD and BC are parallel from here, from my preamble here. AD and BC are parallel. That means they have the same gradient. So gradient of AD is equal to gradient of BC. And that will be equals to 1 over 2. Now, I've determined the gradient of all the lines. The next thing now that we now need to do in order to determine the coordinate of C is to find equation of BC. Equation of what? BC. Don't forget, I told you that any point on the line is sufficient to determine the equation of the line. So on the line BC now, we know the coordinate of B, which is on the line, in fact, the extreme of that line BC. So I will use point B to determine the equation of the line BC using the gradient of BC that we have determined now. So equation of line BC. So the equation of the line BC will now be y minus y1 equals MBC, that's the slope, into x minus x1. So our point is the point B. So y minus 0 equals gradient of BC that we have found, 1 over 2. Times x minus s1. Our s1 is 4. So that will give us y equals, if you open this bracket, so that will be 1 over 2 x minus 2. 1 over 2x minus 2. That's the equation of BC, line BC. All right? Are you with me?
Yes, sir, I am.
Okay. Now, you will see that point C. I don't know why this thing is skipping. Point C is common to, point C is common to line AC and BC. All right? Point C is common to line AC and line BC. So in that context now, I will now solve equation of line AC. You can see that the examiner has given us equation of line AC. So this point is common to both of them. So I will now solve equation of line AC given and equation of line BC that we have found ourselves simultaneously. Is that clear? We'll solve that simultaneously. So 8y plus x equals 64. Call that equation 1. Then equation of line BC that we have found, y equals 1 over 2 x minus 2. Call that equation 2. So we have this simultaneous equation to solve. From your previous knowledge of simultaneous equation, so which method do you want to use to solve this? The choice is yours. So just tell me which method will be appropriate for us to use. Are you there?
Yes, sir.
Yes,
Yes,
I'm
sir, I'm
with you.
hearing you.
What do you say?
I'm hearing you, sir.
Yes, I said which method do you think will be okay to solve the two equations?
It'll be. I'm not sure, sir, actually.
You've forgotten how to solve simultaneous equation?
Simultaneous equations, no, you get the
You can
y
use
and x
you
on
can
one
use
side.
substitution method, you can use elimination method, but the way this has been arranged, I think substitution method will be okay.
Oh, okay. Oh, yeah, substitution makes more sense, yes.
Yeah. So I'll just substitute 2 into 1. So if you substitute 2 into 1, you have 8 into 1 over 2 x minus 2 plus x equals 64. So open the bracket. 8 times 1 over 2x will give you 4x minus 16 plus x equals 64. So 5x will now be equals to 64 plus 16. That will be what? I'm waiting for your response. $64 plus 16, that's what? Ade, are you there?
Yes, sir.
Don't you have your calculator beside you there?
No, sir. Let me get one.
64 plus 16. You should,
64 plus 16
yes.
is
That,
82. No,
no, that should be 80.
80.
So you now divide both sides by 5. So 80 divided by 5 will give us 6 or 16. Let me confirm that. Should give us 16, I think. That should be 16. Yes. 80 divided by 5. That's 16. So S is 16. You now substitute 16 for S in equation 2 to determine Y. So y equals 1 over 2 times 16 minus 2. So that will be 8 minus 2, 6. So C equals 16 comma 6. So that's the coordinate of C. Is that clear?
Yes, sir.
Okay. So write that before we now proceed to finding coordinate of G. Hope you are writing.
Yes, sir, I am.
Okay.
Okay, done, sir. Finish writing it down.
Okay. Now, the next thing now is to find coordinate of D. So to do that, you will need to find equation of line CD. You now solve that with equation of line AC because of the fact that C is common to CD and AC. Hope that makes sense to you. Let me erase this side to put the solution here. Now, don't forget that we have determined the gradient of line CD, which we said is -2 here. And we have also find coordinate of point C, which is which is 16,6. So that is sufficient for us to determine the equation of line CD. So I'll put here equation of Wait, sorry. Let me change the settings of this pen. You know why it's skipping now. Give me a few minutes, please. Okay, let's try it now. Equation of line CD. So that would be y minus y1 equals mcd times x minus x1. So our point for that is point C. So S1, Y1 is 16,6 that we have determined here for C the other time in the first part of the question. So you have Y minus 6 equals MCD, which is minus 2, times X minus S1, which is 16. So open that bracket, you have Y minus 6 equals minus 2x plus 32 minus 2x plus 32. So make y the subject, you have y equals minus 2s plus 38. So that's the equation of line CD. So you will now solve that simultaneously with the equation of line AC given to you. So write that and finish it up by solving this equation that we have just obtained now, this, with this equation of line AC given. So you solve that simultaneously for x and y. So the x and y value obtained there will now constitute the coordinate of D. So I want you to do that. So when you're done, let me know what your S is and what your Y is. But first of all, write this, then you continue by solving that equation y plus 2s equals 38 with hy plus x equals 64 simultaneously. So when you're through with that, let me know.
Okay, so I'm done.
Yeah, proceed and solve the simultaneous equation.
So which two are the equations again? The y plus 2x equals 38. What was the other one again?
Y
The
plus 2x equals to 38. Yes. Solve this equation with this one. Let me
okay.
circle it. Let me circle it. You solve this one. That's the equation of line CD with equation of line AC given this. Oh, no, 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 no. No, that won't solve it. We are looking for coordinate of D, right?
Yes, sir.
No, that won't give you the solution. So find equation of line AD. Find equation of line AD. You already know the gradient of line AD. Where is the gradient of line AD? You said AD is parallel to BC. Am I communicating? From here, we said AD is parallel to BC. So if AD is parallel to BC, that means they have the same gradient. And we have find the gradient of line BC here to be 1 over 2. So that means gradient of AD is also going to be 1 over 2. All right? Does that make sense to you? Hello, Ade?
Yes, sir.
So find equation of line AD. The equation of line AD, use this approach too to find the equation of line AD. You already know the coordinate of AD and you already know the coordinate of A. All right? So find the
Yes.
equation of line AD using this approach. Yeah, do that. So after you have obtained equation of line AD, you now solve that simultaneously with this equation that I circle here.
Wait, is the gradient 1.5
Gradient
of line AD? Is it 1.5?
1/2,
Yeah, okay.
that's 1 over 2. Is that what you are saying?
Yes, sir.
Yes, correct. Now use that with point A to find the equation of line AD.
So is the point D22?
No. What's the equation of line AD you have found?
2y plus x equals 16.
2y plus s equals 16.
Yes, sir.
Check the sign very well. It should not be plus x. Check it very well. It should be 2y minus x.
Oh, yes, sorry, sir. Minus x, yes.
Have you confirmed that?
Yes, sir.
Okay. So yeah. Now solve it simultaneously with that now.
Is it 1214, sir?
Correct. That's correct. Now, this question I've given you is a typical past question. Understood?
Yes, sir.
Yeah, it's a typical past question. So equation of AD is 2y minus s equals 16. 2y minus x equals 16. So if you solve that with the one I circled yellow, you get that coordinate D, which is 12, 14. That's good. So hope you understand the logic now. So anytime you have diagram given like this, you can see we have used all the knowledge we have treated so far, especially the knowledge of gradient. So let's move on to another subheading. So let's look at distance between two points. Distance between 2 points. Or you want to say length of 2 points or length of a line segment. So suppose we have the Cartesian coordinate xy, and let's assume we have this point A here and point B here. So A is at x1, y1, and B is at s2, y2. So to find the distance AB, or we want to say length of AB. Now, this length here is going to be y2 minus y1, and here s2 minus s1. So by Pythagoras theorem, I can say that the square of AB equals s2 minus s1 squared plus y2 minus y1 squared. So this means that length AB is now square root of s2 minus s1 squared plus y2 minus y1 squared. So this is the formula for distance between 2 points. So draw a diagram and write that formula. Then we'll now see example. Are you done writing?
Yes, I almost done writing.
Okay. Are you ready for example?
Yes, I'm done.
Okay. So write this example immediately. Find the length
Hmm?
find the length of the line segment. Find the length of the line segment whose endpoint are 2, 4 and -1, -4. So write that. When you're done, let me know.
Okay, then I finished writing the example.
Okay. So we want to find the length of the line segment. In other words, we want to find the distance between point 2, 4 and -1, -4. So from the points given, 2, 4 will give us S1, Y1. While -1, -4 will give us the S2, Y2. So let me just say AB equals square root of S2 minus S1 squared plus Y2 minus Y1 squared. So you substitute that, so that gives -1 minus 2 squared plus -4 minus 4 squared. And that will be square root of -3 squared plus -8 squared. So -3 squared will give us what? 9. -8 squared will give us 64. So 64 plus 9 gives 73. So you have square root of 73. So I want to leave my answer in exact form. So I will leave it as root 73 units. So that's the length of the line segments whose end are 2, 4 and -1, -4. So hope you are writing that.
Yes, sir, I am.
Okay, when you are done, let me know.
Yes, sir. You done, sir?
Okay. So that will be the end of the class for today. Or, okay, let me quickly take division of line segments into ratios. I think that would be fine, right?
Yes, sir.
Let's do that. I don't know what is wrong with this thing. Why is it skipping now? Division of. Let's stop there. I don't know what is wrong with my pen here. Let's stop here. So we'll continue from here next class. Is that clear?
Yes, sir. Yes, sir.
Let's stop here. All right. So we are going to have business tomorrow so that your midterm break will not start on Monday. So we will not have any work next week.
Yes, sir.
All right. So take good care of yourself.
Okay, thank you, sir.
Bye.
Goodbye.